Now our network atomic solids, carbon and silicon, we get covalent bonds that basically give us a giant molecule. And if you remember, carbon and silicon both, being in group 14 or 4A, have 4 valence electrons, so they can bond to 4 other atoms. In this case, each carbon would be bonded to 4 other carbons in that tetrahedral arrangement. That gives us a diamond, and that's our first picture on the left. Graphite, we get hexagonal rings, where we have, notice, different hybridization, and then the layers are just having weak bonding between them, so that's why a layer will rub off easily, and that's why we can write so easily with pencils. Now in silicon, we mostly have silicon-oxygen bonds, and SiO2 is actually just the empirical formula, not discrete molecules. And so we get Si with O's in all of the different directions, and then the O's can bond to another Si, which can bond to the 4 O's, and so on and so on and so on. You get the idea. Now, silicates and SiO4 2- is the silicate polyatomic ion that we see in rocks and minerals. And when these silicon-oxygen compounds heat and cool rapidly, we get glasses. And glasses are amorphous solids, which just means no crystalline structure. Ceramics are also made from silicates. Which are strong and brittle, but very resistant to heat and chemicals. Porcelain, ceramic, glass, those are all similar to that. We also have semiconductors. And semiconductors are things that conduct electricity, but not like metals. And we can change them. We can make an N-type semiconductor with more valence electrons. Think N for negative because of the more electrons. And a P-type semiconductor where we have an element with less valence electrons. So think P for positive, for less valence electrons.